Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Service Enclosures, the integration of accessible cable chambers beneath pavements. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders, past and present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's long-standing partner, ECHO. ECHO in Australia offers an extensive portfolio of stormwater, building drainage systems, cable pit and ducting systems, access covers and other niche products. The company has just celebrated 25 years as Australia's foremost manufacturer with facilities in Western Sydney, New South Wales. ECHO take pride in providing excellent customer service and extensive technical support from specification through to the finished product installation. Today, we will hear from two speakers, followed by our live audience Q&A, and I encourage you to send questions through to our speakers via the chat box. I'd now like to welcome our first speaker, Bruce Potter. Bruce is a Senior Utilities Coordinator at Cardno, now Stantec, and is a Chartered Engineering Technologist and registered on the National Engineering Register, with over 20 years' experience in civil engineering design and subsurface utility industries. Bruce is a passionate advocate for the challenges of the underground utility world and has written articles about AS 5488 for the Utility magazine for February 2015, 16 and 18 editions, and has presented at industry events, conferences, committees, and is actively involved with numerous industry organisations including Dial Before You Dig and Engineers Australia. Please welcome Bruce Potter.
Thank you, Amanda. Today we're discussing about service enclosures. What is a service enclosure? How do we identify where they are, the types of service enclosures, the applications for service enclosures, and some takeaways that you can take away with you. So what is a service enclosure and how do we identify where they are? So a service enclosure, or a manhole, maintenance hole, pit or chamber, is an opening to a confined space for the purposes of accessing an underground utility to facilitate inspections, maintenance and upgrades. Service enclosures are an essential component of many underground utility networks, including drainage and stormwater networks, sewer networks, electricity networks, telecommunication networks, water networks, gas and petroleum networks. Service enclosures are generally found in urbanised areas, including residential precincts, so any subdivisions where you have single and multi-high-rise building apartments, commercial industrial precincts, including shopping centres, shopping malls, office buildings and warehouses, recreational precincts, including stadiums and parks, traffic and transport, including roads, train stations, airports and ports. Service enclosures consist of two major components: a subsurface structure that connects the underground pipes or conduits, so this is generally referred to as the pit, manhole or chamber, and a surface entry point to the chamber, so this is generally referred to as the lid. In industry, service enclosures are known as pits, manholes, maintenance holes or chambers. So how do I identify where they are? Our main visual clues are the access lids we visually walk over or visually see. So on the left-hand side, we have a telecommunications pit that you'd normally see in a residential area. The picture in the middle is a telecommunications pit that would contain large conduits and cables. And the picture on the right is a stormwater manhole that's in the road. So this would actually indicate that there's a presence of an underground utility with the pit lid that you see. The first step to obtain information about a public utility is to lodge a Before You Dig Australia. So this used to be called Die Before You Dig Australia, and they've now changed their name to Before You Dig Australia. Or if you are working in an area where there's private assets, such as a private airport, you'd need to contact the relevant organisation. So Before You Dig Australia information is considered to Quality D of AS 5488.1 2022 and should only be used as a guide for presence of underground utility. Other sources you can obtain information may include topographic surveys or via utility locators, which might actually provide photo maps or their own utility surveys. In engineering design, the topographic survey would normally contain the lids of the existing utilities. These would be labelled to the type of utility asset, such as drainage or sewer or electricity and communications, and assigning this to Qual Level C of AS 5488.1 2022 for a surface feature. This indicates that there is a presence of an underground pit, manhole or chamber with pipes and conduits connected when combined with the Qual Level D information from the Die Before You Dig or Before You Dig Australia search. You can obtain more information from by opening the pit lid, and that's usually done by the asset owner or an accredited utility locator. So utility locators form an important part of finding out information about what's inside of a chamber or a pit or a manhole. They can make observations, they can undertake condition assessments. So the picture on the left-hand side is a CCTV investigation of an existing sewer. The first two little photos you can see on the right-hand side of the left picture are the underside of the manhole. The picture in the middle shows an existing telecommunications pit in a CBD area, and that shows the conduits and the conditions of the substructure underneath. The picture on the right-hand side shows another telecommunications pit, but this one is actually full of water and muds. So now we move on to the type of surface enclosures. So pits are generally associated with electricity and telecommunications assets. They are generally found in the footpaths or sidewalk pavement areas or pedestrian-centric areas such as shopping malls or shopping centres. They are considered as non-trafficable or light duty. The pit is generally made of unreinforced concrete or hard plastic, and they generally contain concrete infilled pit lids. And there is also options there for textured concrete infill lids to match the surrounding aesthetics. So the picture on the right-hand side, the top, shows a telecommunications pit. This time it's TPG in an existing footpath. The picture down the bottom shows an existing telecommunications pit in a mall area with textured tiles around it. Next, we talk about manholes. The manholes are generally associated with stormwater and sewer assets. They are considered as non-trafficable, but also trafficable. So in the case of non-trafficable, they can be found in footpaths and sidewalk pavements, pedestrian-centric areas such as shopping malls and shopping centres. Their manhole is usually constructed of reinforced concrete, and the lids are usually cast iron or concrete infilled lids. And with the concrete infilled lids, they can be textured to match their surrounding aesthetics. So the picture on the right-hand side shows an existing sewer manhole lid, and that's in an allotment. So now we move on to manholes in trafficable situations, and these are generally found in flexible and rigid pavements such as cycleways, car parks, roads, and airport aprons. Again, they are generally constructed from reinforced concrete, and the lids this time are cast iron or concrete infill lids, but they are trafficable type, so they are much more heavy duty. And there's options for bolted down lids. So now we move on to chambers. So chambers are generally associated with any asset that contains a surface opening to a larger confined space area that contains larger pipes or multiple groups of conduits. They can be considered as trafficable or non-trafficable. So in the case of non-trafficable, they can be found in footpaths and sidewalk pavements, and in pedestrian-centric areas such as shopping malls and shopping centres. They're made of reinforced concrete, and their lids can be cast iron or concrete infill lids. And again, similar to pits, their pit lids can be textured to match the surrounding aesthetics. So the picture on the top right-hand side shows inside of a pit inside of a sidewalk in the CBD area. And the picture down the bottom shows a cast iron lid in a footpath area. So now we move on to chambers in trafficable areas. And again, these are in flexible and rigid pavements such as cycleways, car parks, roads, and airport aprons. Reinforced concrete they're made of, and the lids can be cast iron or concrete infill traffic lids. And again, they can have options for bolt down lids. So now we move on to the application for service enclosures. So pits, manholes and chambers are in almost every project, including Greenfield projects, which is defined by any project that lacks constraints by prior works, or a Brownfield project, which by definition is a project that contains prior works that may impact the design you're currently working on. So both Greenfield and Brownfield projects may contain non-trafficable and trafficable access lids, pits and manholes that require different factors considering the applications you are using them. So in the case of Greenfield projects, the overall considerations here is the risks are generally lower than Brownfield projects. The design constraints is generally limited to the project coordination and constructability considerations within the project itself. Safety and design risks are generally lower and more manageable. And the durability and maintenance of pits, manholes and access chambers are lower because they are considered as new. So as you can see there in the picture on the right-hand side, we've got a brand new urban development site there, and contained within that, you'll have your stock standard pits, manholes and chambers associated with that project. So now we talk about in Greenfield projects, non-trafficable. So what to consider for pits, manholes and chambers? Well, they're primarily based on standard corridor widths and verges in road reserves and considered as reticulation. Pits, manholes and chambers and their associated pipes and conduits are generally designed to standard verge depths. The loads on the pits, manholes and chamber depths are considered as light duty under footpath and pedestrian-centric areas. As discussed before, they are generally unreinforced concrete or hard plastic. And the safety and design considerations for constructability, access and maintenance are considered as standard in line with operations and maintenance. As you can see, the picture on the right-hand side there shows a typical scenario in a verge situation with a reticulated telecommunications asset. So now we move on to Greenfield projects, trafficable. So what to consider for pits, manholes and chambers? Well, they're primarily based on reticulation, but they can also contain trunk utility assets or assets that are unable to be designed in the standard verge corridors. So you may have a situation where you have high voltage electricity that does not fit in the verge that needs to go under the road pavement. Pits, manholes and chambers, including pipes and their associated conduits, are designed deeper to accommodate the road pavement design. The loads on the pits, manholes and chamber structures are considered as heavy duty, and as discussed before, they are made primarily of reinforced concrete. The loads on the pits, manholes or chamber lids are considered as heavy duty, and again, cast iron is generally what they're made of, or concrete infill lids. The access lids are considered as heavy duty. Safety and design considerations for constructability, access in trafficable areas are to be considered. So when we're placing these sort of things in the design world, we should be placing them as close as possible to the existing curb line, where we can actually think about maintenance in roads, where we can shut off the road without affecting multiple lanes. So now we move on to Brownfield projects. So overall considerations, the risks are generally higher due to constraints that may affect the designs. So there's lots of moving parts that sometimes you're aware of and sometimes you're unaware of, or you're obtaining more information about them. It relies on the collation of existing utility data. So in this particular case, you would have to map the existing utilities that are on site to make sure that you are fully aware of what's currently underground. You would need to identify the existing pits, manholes and chambers to be modified, being raised or lowered against the design levels. So this means that you might have an existing telecommunications pit that may need to be raised to the final surface levels. The pits, manholes and chambers need to be structurally condition assessed to determine if they are fit for purpose. So some of these pits that you may see may actually be degraded. So you will need to actually pull out the entire pit and replace it with a brand new pit. You'll obviously need to obtain approvals from the asset owners. Safety design risks are generally higher and may require inputs from multiple sources. And the durability and maintenance risks of pit, manholes and chambers are generally higher because we're generally retrofitting, unless of course we are putting in a brand new asset, in which case then it is not as high as retrofitting. So brownfield projects in a non-trafficable situation. So what to consider for pits, manholes and chambers? Well, they generally adopt the standard corridor widths and depths under road reserves where practical, but are based upon the utility data and new designs. So if you have mapped the existing data, the utility data, and you have a design, you need to understand where you can actually place these new assets. Structural condition assessment of existing pits, manholes or chambers identified as maintained and modified or raised or lowered to new design levels. The loads on the pits, manholes and chambers are considered as light duty under footpaths and pedestrian-centric areas, and again, the unreinforced concrete or hard plastic. Access lids are considered as light duty, so concrete infill or hard plastic. And the safety design considerations for constructability, access, maintenance are considered as a case-by-case, adopting standard operation and maintenance principles. So as you can see here, we have a picture on the right-hand side. Again, it's in a CBD area of an existing telecommunications asset. If this is going to be raised or lowered, then we'd need to do an assessment of the existing pit itself to see if it's actually fit for purpose. So now we move on to brownfield projects in a trafficable situation. So what to consider for pits, manholes and chambers? Well, they're primarily based on reticulation and trunk road crossings or trunk utility assets designed deeper under flexible and rigid pavements based upon existing utility data and new designs. So what that means is that unlike a Greenfield project, you will need to look at what existing constraints you have with the existing underground utility data and whatever it is that the design is doing. We'll need to do a structural condition assessment of the existing pit, manhole or chamber, identified as to be maintained and modified, so you may need to raise it or lower it to the new design levels. The loads on the pits, manholes and structure are considered as heavy duty because they're made of reinforced concrete under flexible and rigid pavements based upon existing utility data and new designs. And the access lids are considered as heavy duty cast iron. Safety design considerations for constructability, maintenance and trafficable pavement areas are considered as a case-by-case scenario. And again, similar to what happens in brownfield sites when we have, in greenfield sites when we have trafficable situations, we need to consider the accessibility of these assets. So whoever's maintaining them doesn't need to take out many lanes of traffic in a highway situation. Where they're contained in one single lane where we can actually take out a lane and not adversely affect other traffic. So now we come along to the takeaways of all this presentation. So what you should take away from this presentation is the pits, manholes and chambers are absolutely everywhere. We continue to design them in every project that we work on, but there are also many of these assets that are currently existing. Some of them are in good condition, some of them are in not so good condition, and some of them are somewhere in between. We need to also understand the differences between the pits, manholes and chambers for the various types of utilities and their applications for them. The differences between non-trafficable and trafficable pits, manholes and chambers on the various types of pavements. So when you are specifying something for a footpath pavement, or something for a flexible road pavement, or something maybe in an airport's apron, they're all going to have different scenarios to consider. Pits, manholes and chambers and Greenfield projects rely on correct specification depending on the application, and they're basically considered as new assets. The pits, manholes and chambers and Brownfield projects relies on condition assessments and considered as retrofitting. And of course, that's all based upon existing data that we collect. So that concludes my presentation for this, and I'll now hand back to Amanda.
Thank you, Bruce, for that great presentation. And now I'd like to welcome our second speaker, Greg Facey. Greg is the Market Segment Manager for ECHO and began his career with the organisation back in 2004 as Queensland Specification Representative, providing education and project solutions to many state authorities, engineering and architectural firms. Greg progressed into the current market segment role, providing education, CPD support, technical advice and design brief development nationally to industry associations, transport authorities and designers in the stormwater management space. Please welcome Greg Facey.
Hi, and welcome everybody to today's webinar on the ABC of surface enclosures. In today's industry, there's a wide range of traffic-all enclosures in various materials, which includes non-conductive plastic material, cement concrete, GRC, which is glass reinforced concrete, and polymer concrete. There's also a wide choice of lids and access covers to meet the anticipated load requirements. Covers may vary from non-locking and standard locking to high security designs to meet the specific client and government requirements. Cover and frame systems also provide secure protection to cable enclosures and enable decorative floor finishes to be maintained with minimal interference. Today, we'll discuss the key requirements when selecting service enclosures, cover and frame systems, as it's important to understand the correct enclosure for the application. So in today's presentation, we're looking to achieve an understanding of the types of enclosures, their uses, the factors to consider when specifying them across a wide range of applications, and also an understanding of the lids and access covers and how they can affect the performance of the enclosures as well as their physical and visual integration with the pavements. Because understanding this is really important in terms of cover durability and pavement life, because incorrect product selection, poor product or incorrect assessment of the site conditions can lead to failure of the system, and failures occur for a wide variety of reasons. However, understanding all the aspects of the enclosure system is critical to long-term performance. So if we consider the types of cable service enclosures, cable pits are positioned on cable routes to provide branching or bending points or to allow access for jointing and maintenance. Common cables are routed through cable pits through data communication or fibre optic cables, and also low voltage electrical wiring. Just remember that generally higher voltage cables typically go overhead or extremely deep underground. In contrast to this, surface cable ducting systems become the cable route themselves and allow for low voltage cables and other utilities to be laid directly along the trafficable pavement. They can be continually accessed through removable covers, and the structure enclosing the services is typically continuous. These are often in the form of either precast sections with smaller widths with covers up to 300 mm, or can also be cast in situ systems for wider width requirements. A cable closure is designed to protect its contents, so its cables, connectors and equipment, against external influences. The structure also needs to act as a shield to prevent its potentially live contents from causing damage or injury to passers-by. Cable pits are commonly positioned where the cable run is required to change direction, and this is because bends in underground conduits are undesirable. Cable pits are also used for drawing or hauling, is another term, of the cables, also called pulling boxes, and they are used for pulling cables into the enclosure using pulling equipment or looping or feeding it into the next enclosure along the length of the cabling system. Each drawing pit conduits are generally aligned with the opposite walls at the same elevation. AS 3084 stipulates strict requirements for cable pulling so cables aren't damaged during these operations. Jointing pits, which are also called splice boxes, are intended for enclosing a splice cable connection. These pits contain waterproof cable joints and are generally placed along straight sections of the cable route. These cable pits must be correctly sized to accommodate the size of the connector and also the cables running through it. Some common equipment in service enclosures are cables, so data and communication, fibre optics, low voltage electrical wires, and also they're used not just for electrical cabling, but also for other uses, as in gas, fuel and water supply and valves, housing stormwater and sewer junction pits as a junction pit, and also housing equipment, i.e. Transformers and pumps. But locating services below ground enhances the appearance and also improves access by service personnel. So there's four key factors that need to be considered when selecting service enclosures systems. Choosing the right enclosure for the right application, particularly during the planning and design stage, is essential to prevent both problems and product failures in the future. Some of the important factors to include is we need to consider the size of the enclosure to ensure the utility asset is housed appropriately, the location and all intended loads in each of its locations. The type of traffic loading will also play a significant part in selecting the correct product. For example, a light vehicle versus a heavy vehicle or forklifts will exert different loads on the cable enclosure. Durability of the materials, both of the enclosure and the cover, and ground conditions and location also play a significant part in the durability of the enclosure. We need to consider the safety and security of the enclosure. So we need to consider what the level of that security is required and also the user and public safety. Considering the site and user requirements with the installation and maintenance of the enclosure, how will this enclosure be installed? Ultimately, a contractor will pick up the drawings and need to carry out the installation. So it needs to be easy to install, or is it a time-consuming enclosure which is going to add more cost? So choosing the correct enclosure can have a direct impact on costs. Ultimately, the asset holder undertakes the maintenance in most cases. So how is the enclosure or the system going to be maintained and carried out in an efficient and safe manner? We understand the aesthetics and identification are also important. At the end of the day, we need to consider at the pavement level how the aesthetics are going to integrate and harmonise with the surrounding pavement. So choosing the correct enclosure size will depend on the following: the purpose of the enclosure, the minimum bending radius of the cables, and refer to manufacturer's cable recommendation. Minimum depth to cables, so you need to refer to those standards, and is segregation of the cables required? For example, it may be low voltage electrical or maybe communications. And will the pit be used for storage? And most cable pits are narrower at the base for ease of manufacturing, so you need to make sure you consider the clear opening of the cable enclosure and the pit, and also its minimum dimensions. We also need to consider the location and particularly the traffic and loading, because there is no Australian standard that applies to service pits. So we need to consider the anticipated traffic scenario over each of the enclosures. So is there no anticipated traffic? Is there some accidental, or will we deliberately traversed by vehicles? The wheel type and the loadings during the construction and during the service. Often we've seen pits that have, for example, may be utilised in a light duty application, but however have been traversed by trucks and vehicles during the construction phase, which damages the pit. So all those phases during the construction phase need to be considered, and also importantly, during its service life. A single cable route can pass through a number of different environments, and every service pit along the cable route may be exposed to different scenarios. So what they're saying is in one location on the cable route, it might only be a light duty application because there's no vehicles traversing it, but that may not be the case throughout the entirety of the cable run. So we don't want to be specifying the covers or the pit or the light duty applications when we know it's going to be traversed further down the cable route with trucks. Alternatively, we don't want everything to be extra heavy duty when it's not going to be traversed necessarily, because that's adding more cost. And a lack of consideration can lead to over-design or causing more cost, or can also lead to failure. The correct enclosure construction type affects the durability, which needs to be assessed during the project against the project requirements. Some common materials for the cable enclosure is polymer concrete, so cast in situ or precast, so essentially a Portland sand and cement with reinforcing. Plastic, which in the form of either polypropylene or polypropylene, GRC or glass reinforced concrete. We also need to consider the correct installation of the pit. So the pit might be fit for purpose, but it's really important that it's installed correctly. And also we need to also consider the life of the adjacent and supporting pavement, which can have a direct impact on the cable enclosure itself. So if we look at some of the different materials and how they perform, you can see here briefly, polymer concrete has a lot of advantages to it as a construction material on surface, and certainly for a cable enclosure in the form of a pit. Lightweight, low porosity, excellent insulator, excellent chemical resistance, non-flammable, high resistance to weathering, and low coefficient of expansion and contraction compared to that with plastic. And plastic does have advantages, very light, easy to use, easy to create penetrations. There has been some advancements in the industry where typically plastic pits were always what we would call a light-duty single-walled pit. However, there are other pits available that are now in the form of a twin wall, which can be utilised in heavier duty applications. They are an excellent excellent insulator and have high chemical resistance, but they are flammable. They do have low resistance to weathering, and certainly in single wall pits have a high coefficient of expansion and contraction, which means that the actual material can move in and out with different levels of heat during the day. If we look at also concrete and GRC, one of the main things with concrete is we know it's heavy, so does it need lifting equipment to move it around? It does have moderately smooth walls and average porosity. It does require steel reinforcing to support it, but generally not required under a wheel load. It does have poor chemical resistance and poor resistance to biological attacks, but it does have a lower coefficient of expansion and contraction. Look, GRC, if you're not familiar with GRC, it's a fine aggregate of water and chemical admixtures and glass fibres, so not to be confused with concrete because it's generally not reinforced. It does have an advantage that it's lightweight, but it does have rough walls, which is a disadvantage. It does have high porosity, which is a disadvantage, poor chemical resistance and poor resistance to biological attacks. It is non-flammable, but it is worth noting, particularly with GRC in aggressive environments, it is prone to deterioration, particularly with alkaline soils. So therefore, GRC pits require regular maintenance and in some cases are susceptible to early failure. And adverse ground conditions may require an increase in these dimensions of the pit and or the addition of reinforcement. And if in doubt, seek engineering advice, because soils can apply lateral pressure on the structures just in the form of its own weight and any surface live loads adjacent to it. And we also need to consider any expansive soils and their properties. And as I mentioned, they can result in lateral earth pressure exerted on the pit wall itself and can lead to early failure. The location of where the service enclosure is going to be installed is paramount, and understanding what pits are suitable for what application is also really important. So in a landscape environment, with light duty lighting on a pit structure allows the use of a flexible pit. So we're talking about a single walled, or could be a twin walled plastic pit in this application, but generally single walled. Materials range from fiberglass, so resin and glass mat structure pits, or plastic in the form of rotational or injection moulding. And again, the advantage is they're light, robust and easy to use. If we move on to and consider solid pavements, so these are pavements subject to vehicular and pedestrian traffic, a rigid pit is recommended. So a rigid pit in the form of either a concrete pit or a polymer concrete pit, so non-flexible walls. And these are in the form, as I said, FRC, so either in a precast fibre reinforced product or Portland cement concrete with steel reinforced. Can also be cast in situ, so these are boxed up and poured on site, and polymer concrete in the form of precast resin composite material. The advantages, they're strong, rigid and they're versatile. And a Class D iron cover on a single wall plastic pit is not recommended. And often we've seen this, whilst the cover is Class D, a single wall flexible pit is not suitable for a heavy Class D loading. So do not use Class D access covers on a single wall plastic pit, and you need to use a rigid pit under a Class D load. And rigid pits can be used right up to a Class G environment, but you need to seek manufacturers' details on how both the cover system and the pit needs to be installed in those environments. Understanding the requirements of the location will determine the selection of the enclosure and also the cover. And collaboration with all the stakeholders may be required, particularly in high aesthetic application. This ensures not only the functionality of the enclosure is met, but the aesthetic form is also achieved to meet the visual requirement of the project. And we need to consider the safety and security requirements of the enclosure, because we see, I guess, heavier security forces in our daily lives and events, and it's not hard to notice the sharp increase in supervision as we go about our daily lives. And sadly, some of the destruction stemming from the divisive political, religious and ideological beliefs continues to tick over in the world, unfortunately. But now more than ever, the importance of national security to keep our country as safe and as secure as possible has never been more prevalent. Why do we need to protect ourselves? We need to withstand the disruptions to ensure the safety and well-being of all our residents. We seek, as asset holders and designers, to secure our cyber security systems, and also there are processes in place to protect our national data. To reduce the risk, we adapt a critical resilience approach to the integrity and reliability of our cable infrastructure in the form of high security pits. Therefore, we need to consider all the requirements and standards when selecting the enclosure. And once an appropriate location for a cable enclosure is determined and the conduit installed, preparations can be made for digging and enclosure installation. If you need to remove a full wall of the pit to install more conduits, you probably need to look to go to a larger pit to retain a portion of the wall. And designers and contractors must observe the regulations and codes of practice legislated by the Electrical Safety Act and refer to manufacturers' standard installation drawings for guidance. The correct pit type ensures long service life. So we look at the different types of systems, so GRC, FRC and polymer concrete. These are utilised for small to medium enclosures, generally off-the-shelf items installed with either concrete, mortar collar or encasement if they're used under some trafficable loads, and can be used for all types of applications. With single wall plastic pits for small to medium applications, they are also off the shelf. They do require concrete mortar and collaring and encasement if used under vehicular traffic. When I say vehicular traffic, this would be only very light duty applications, i.e. say a footpath, for example, or a landscaped area that might be traversed by a vehicle or mower, for example. Double-walled plastic pits, they're an advantage at, well, certainly very lightweight, but they also generally larger enclosures, so from medium to large, off-the-shelf and or custom dimensions. Encasement is required in heavy-duty applications and can be used for all types of applications. And then concrete, which is suitable for medium to large, off-the-shelf and custom items, but generally no encasement is required in heavy-duty application, and reinforcement is not required because just the nature of a precast concrete pit, they're quite large, heavy, thick-walled and have reinforcing, and they're suitable for all types of applications. With many of the pits and cable enclosures available on the market, whilst we want to achieve a high security level of pits for whatever the client requirements might be, we also need to consider ultimately how is it going to be maintained and accessed, and importantly, how the covers are locked down. Now, the market and the industry has progressed from using, say, a locking bar, which you would see on the top left, which was utilised to lock the pits, but this can unfortunately allow cables to touch the bar, and it can also make the covers live. So some of the advancements by manufacturers was to remove that bar to more of a barless application, which removes that bar completely and takes away that risk. Because we want to reduce the electrocution and also improve the slip resistance. So metal components within the enclosure should be kept away from the electrical cables, and absence of locking bars are the best solution here. And if required, pits should be connected to an earthing structure of a building or construction via earthing strap by the eye. The top surface of all lids and covers should provide at least the same slip resistance as the adjacent pavement to meet the requirements of AS 4586 and HB 197. So we don't want to have the cover a high slip resistance than the adjacent pavement because it can have a mismatched grip level. So where possible, we want to try and have the slip resistance of the cover as close to as the adjacent and surrounding pavement. We do need to consider the site and user requirements, importantly the worker safety and any foreign materials and the lifting of the covers. So ingress of foreign matter, we need to consider because excessive ingress may make the service enclosures hazardous, and we require a degree of protection which is required against objects like needles and fingers, etc. And that's expressed as an IP rating to AS 60529. And the lifting of lids for maintenance must be in accordance with the National Code of Practice for Manual Handling. And manufacturers should actually be able to provide the weights for all products and lifting devices be independently certified. Heavy castings should have lifting anchors as well to provide ease of lifting. If we take a look at the water resistance requirement, service enclosures are not designed to be waterproof. However, there is a reasonable degree of weather resistance that can be achieved by the sealing of covers by either capping and lifting holes each time a cover is removed for servicing. And entry holes for the conduit should be capable of being sealed to prevent siltation. Pit drainage is recommended, particularly for pits positioned at sag points. If a higher level of water tightness is required, and often we get asked this, ductile iron cover can be utilised. Sealed with grease would be the next option, and we'll explore those covers shortly. We also look at the cable management within the enclosure. Segregation is not uncommon, particularly on public transport applications where different systems must be segregated, i.e. you could have CCTV cables, power and hearing loops. And if we consider any cable accessories, so if required, PIT should also allow for easy attachment of cable pulling equipment, step irons, hangers and brackets, bell mounts and bushes and etc. And split pits may be required for pre-existing cables. So these are pits that can be installed within an existing cable route and over and around the cable. And cable enclosures for dual services, as I mentioned, may require segregation. Here's a good case study here of Pat Rafter Arena, where they use for the use of a cable ducting system with removable covers. So they utilised this system because they wanted to run TV cables where they were doing filming at the various courts. So they remove the covers, or they'll put the cable in, pull the cable through. But where they might be doing the filming, for example, they'll remove the cover, barricade it, have an isolated area, and then when finished, they can pull the cables back through and put the cover back on. So that was a really ingenious way of using a cable ducting system, which is exactly what it's intended for. Importantly, we need to consider any load standards, but there is no Australian standard that applies to service pits. It's because AS 3996 governs only the access cover and lids. And the access covers and lids bear direct live loads on top of the enclosure. So there are requirements. We need to consider the load classification. And compared to AS 3996, the deflection criteria have increased from 210 kilonewtons to 240 kilonewtons. We also need to consider the durability of the service enclosure and also the water tightness. A manufacturer should be able to provide independent certified test certificates. Look, it's easy to confuse the wheel weights with the wheel loads, and it's a question that gets asked often. I'm driving a truck over a service enclosure. I need, extra heavy duty, or need it to be class G, for example. But it's important that we don't confuse the vehicle weights with the wheel loads, and service pits should not be placed in areas of fast-moving traffic, i.e. roads. AS 3996 gives an approximate slow-moving wheel load. So that's what we need to consider, that the single wheel load that's going to be applied to the service enclosure and cover. So consider the axle exerting the greatest load and divide to reduce this load to only the wheels that will make contact with the lid. So what this does is make sure that it's the correct cover for the wheel load, and also reduces the chances of the cover being overspecified, I guess. If we look at the different cover and lid types, lids have either a solid top configuration and fit directly into the service enclosure structure. Access covers comprise of a separate cover and frame system installed integrally into the pavement or slab. They do not sit directly on top of the pit. They are fully supported by concrete, which you'll see on the middle image. Often, and we do get asked, and I have seen covers and frames placed directly on top of the pit and then concrete poured around it. That is incorrect. So the cover and frame must be fully supported and independent of the pit. And cover and frame systems have an advantage because they can either be a solid top or an infill cover to accommodate the pavement material, so they can blend in and harmonise with the surrounding pavement. If you're using standard lids, ensure that the top of the pit is also level with the finished pavement. If access covers are used, the top of the pit must be set down beneath the pavement level. So depending on the installation, certain user requirements are considered critical to the asset owner or maintenance crew. So we need to look at the access frequencies, how often is going to be access. Is there a requirement for protection against foreign objects, slip resistance, what's the aesthetic requirement, Does the enclosure require any identification, so i.e. electrical, communications, etc.? And what is the security level? And lids and access covers are available in a number of security options in the form of either a standard bolt, a security bolt, in the form of padlocks and high security padlocks. In non-sensitive areas, heavy access covers generally do not require locking bolts, particularly if frequent access is required just due to the nature of the weight of the cover itself. But manufacturers should provide solutions to meet unique client requirements. So we have a look at access covers and their materials. Some of the factors to consider is the type and frequency of traffic, because that'll determine the cover type and material. Is there a corrosion resistance requirement, and also the weight and handling of the cover itself. The different types of access covers are either in square or rectangular or circular configuration, available in single, so that's a single cover, or two-part covers or three-part covers. Solid top covers are required to meet AS3996 slip resistance for the wet pendulum tests, and that data is available on the slip resistance chart. There's two classifications of infill covers, covers requiring structural infill and covers not requiring structural infill. The manufacturers should provide clear installation guides, particularly for covers requiring structural infill. But we also need to consider the aesthetics, where the enclosure is being placed in the pavement, and does it need to harmonise and blend in with the surrounding pavement. And that's the advantage with infill access covers, because they allow that visual continuity along the pavement or the floor. Decorative edging in the form of either stainless steel or brass trims will enhance the appearance of the cover and frame. And edging for iron access cover is often standard if pavers or tiles are being utilised. If we look at the size and the orientation of the access covers are specified by their clear opening, so not the overall dimension, the clear opening, and that's the unobstructed clear opening of the frame. Iron covers are only designed to move in one direction, and they are specified by the width and also the length. So that's the width across lifting points and the length parallel to the direction of removal. And also ensure obstacles do not impede the cover removal. So this is a really good example, this image here, which shows the cover was incorrectly installed. So this multi-part cover, it was installed in the wrong direction. So unfortunately, they didn't understand the removal direction of the covers, and the covers unfortunately can only be removed up against in the direction of the wall. During the installation phase, it needed to be considered and to be turned around so the covers could be moved away from the wall. So these little things are really important during the construction phase. We do need to consider the workplace health and safety and the lifting access of covers. And cover and infill materials influence the lifting weight. So AS3996 requires the cover to have permanent markings showing the approximate mass of the cover, including any infill. And according to Safe Work Australia, lifting, pulling, pushing requirements vary across each of the states and territories. Mechanical lifters in the form of either long or short keys are designed for easy lifting. So they just provide more leverage and easier lifting of those, particularly iron infill covers, which can become quite heavy. And manufacturers need to specify the approximate lifting weight on all access covers. We have a look at the weatherproofing of access covers. AS3996 does give performance criteria for gas and water tightness, and covers can be sealed in different ways, including the use of grease. If sealing is required beyond 1 kPa, then bolts are recommended. It's also worth noting with grease, it's important that when covers are removed, iron covers are removed, that they should be re-greased each time put in, because not only does it help with waterproofing, but it also means that the cover is easier to remove the next time. With the security of access covers, bolts are required to fasten the covers into the frame for security and also if there's any anticipated back pressure. And where there are gases, there's potential for uplift, which is why bolts are utilised. And in some instances, bolts need to be designed for the application, i.e. stainless bolts are recommended for durability. Outside of what we would consider a standard or off-the-shelf access covers and cable enclosure in the form of pits, there are other engineered solutions, and these are in the form of a multi-part system for very large enclosures. And multi-part systems are custom built using standard parts and pieces. Covers are supported by a beam and continuous frame systems. All covers and the beams can be removed to provide full, uninterrupted, clear access to the cables or transformers below. And trench runs are surface ducting systems for wide trenches. So these are cast on site. So the trench itself is cast on site and the covers are supplied by manufacturers. So the trench runs are custom built using standard parts and pieces, and like multi-part systems, trench runs can accommodate all types of flooring materials. So in the form of either can be a solid top cover or an infill cover, as you can see on the bottom left-hand image, to blend into the surrounding pavement. If we consider the weatherproofing on multi-part covers, AS 3996 does not govern over large access cover systems, purely because due to the number of removable components, including the beams and individual covers. Multi-part covers, by their very design, cannot be made watertight. Multi-part cover systems are suitable for applications requiring general weather resistance on well-drained enclosures. But it's really important that multi-part systems are installed correctly, and they do require careful planning. The load class and pit clear opening of the pit must be confirmed, and the slab design needs to provide for the beam, the frame depths and the locations for the multi-part system. And manufacturers should be able to provide rebate and cover schedule drawings for every unique multi-part system. So what I'm going to show you here is just a brief typical installation of a multi-part system. So you can see here where the parts and pieces have been delivered on site in the form of the frames and the covers. Then the pit is formed to the rebate details, and then the contractor will start to set out the frames, the wall boxes, and level the frames out. Then start to install the beams. Then they'll set up the internal formwork to ensure that the frame will be fully supported after the concrete pour. And then start to place all the covers in place and make sure all the covers are level and are not rocking before the concrete pour. And they'll replace all the dust caps, and so there's no holes within the cover system itself, and simultaneously fill the covers and also the rebate gap. So this is a gap between the frame and also the precast or the cast in situ pit, and also all the cellular frames as well. And they'll screed off any excess concrete and wait for it to cure. So as you can see, there's a fair bit of planning and consideration that needs to be considered during the installation of multi-part access covers. And here is a really good example of a multi-part access cover system and its use. And whilst we talk about cover and frame systems, and ideally we think of electrical cables, this is a really good example of a cable enclosure that wasn't used for cables. So this is Shell Aviation at Brisbane Airport. The fuel pipeline installation needed to comply with some of the stringent safety requirements, and shut-off valves are strategically located along the pipeline. And one of the shut-off valves was actually located airside between both terminals, but was regularly trafficked by taxiing aircraft. So a large, heavy-duty enclosure was required. And there are also some other engineered solutions in the way of access covers where for frequent access to utilities or machinery beneath is required, and these covers are hinged to the frame with a gas strut and a hydraulic arm which allow for easy opening, and the system contains a rubber seal ensuring a gas and watertight seal. And when open, a galvanised steel safety gate falls into place to stop, and a stop latch holds the cover open to prevent the cover from accidentally closing. And just to finish off the webinar, all this information today is available on the ACCO's service enclosures site, www.accocablemate.com.au, where you'll find all our polymer concrete pits, polyethylene pits, our SCEC approved pits, our twin-walled easy brick pits, access covers, and also our standard and locking lids. ACCO manufacture not just cable enclosures, but a variety of surface water management systems and utility enclosure for all applications. Ask ACCO is a global initiative providing you with ACCO's expertise, and we're here to help you select the most appropriate products and create a whole system design that will stand the test of time. So our extensive expertise is available to you, no matter what your interest or role. And if you click onto www.askacco.com.au, that will take you to all our services where we can assist you as a designer. And for access covers, we do have an online configurator in the form of Atrix as well. So thank you for attending today's presentation, and I look forward to your questions.
Thank you. A big thank you to Bruce and Greg for your presentations this afternoon as we discuss service enclosures, the integration of accessible cable chambers beneath pavements. It's now your turn to get involved. Please, as always, ask our speakers questions via the chat box, and please put down who your question is directed to. And a big thank you to everyone who put through questions whilst registering. And I'd like to take the opportunity to welcome Darren Chan, Brand Manager for Civil Construction Products at ACCO, who will be joining us for the Q&A session. So without further ado, kicking off with you, Greg. We've had a question that's come in from Sabramian from New South Wales asking, what are the specific products ACCO has in terms of pits? Greg.
Yeah, excellent. And thanks for that question, and thanks for your attendance today. Look, I think one of the unique things about ACCO is that we make a whole wide variety of pits. So not just single wall plastic pits for light duty applications, but we are very broad in terms of our product offering. So light duty plastic single wall pits, twin wall pits for heavier duty and custom applications. We also manufacture high security pits for the SCEC requirements, and we also do rigid polymer concrete pits. So that's really ACCO is quite unique in that aspect. So all those pits and products that we manufacture, and we manufacture here in Australia as well, proudly, and all those products are available at www.accocablemate.com.au.
Thanks for that, Greg.
With that for Greg. As Greg said, we're an Australian manufacturer. We actually have our manufacturing plant out here at Emu Plains at Western Sydney, and we actually make our rotational moulded plastic pits here in Sydney, along with our polymer concrete pits, and also the cement concrete pits that we make for our SCEC range is also made in Australia. So they're all locally made, and we have offices and warehouse in all the major cities around Australia to service all the different markets. So we're a very proud Australian-made manufacturer.
Thank you for that. And just staying with you, Darren, for the moment, and then maybe Bruce, you can hop in. We've had a question that's come in from Timothy in Queensland. Good afternoon, Timothy. Asking Darren, should stormwater drainage be provided to service pits?
Yeah, with service pits, obviously the things within a service pit are very important infrastructure, and obviously we don't want water to get in there and damage it. So we try to protect these pits. They have to be well designed. So first of all, you'd probably want to design your pits in an area where it's not in a sag, so not all the water on the adjacent pavement is flowing down to the pit and going in between the pit lid and the pit and into the pit. So what you want to start with is make sure your pit is elevated slightly above the pavement, so all the water falls away from the pit, and only water that really just rains on top of the lid may get into the pit. Sometimes you might get some water going into the pit, and then we've got details showing how to drain the pits. So you can put a pipe out the bottom of the pit into a little soak away, into some blue metal away, piped away, let the water drain away. Last thing you want to do is have sitting water inside the pit. You've got to have some live wires in there, which can pose a hazard to the maintenance person. So it's very important to drain the pit, and so it's safe and ready to go when I suppose it needs to be serviced and there's no hazards within the pit. So those things definitely, yes, we'd recommend putting a good design and having the pit dry and drained away so there's no water sitting inside.
Thanks, Darren. Bruce, do you have a view?
Yeah, thanks, Timothy, for your question. I guess putting in pits and drains and things like that, you obviously have to understand your safety design and your maintenance regimes as well. So, what we'd like to put pits and manholes underneath everywhere, that may not be the only solution. So, you do have the option there if you have swales or overland flows and things like that to consider designs outside of pipes. But in the case of piped and pit situations, pretty much what Darren was just explaining before, where obviously you got on-grade pits and sags and things like that. So have a look at your design levels, have a look at your catchments and your flows, and how much water and stormwater you actually have in your catchment.
Thank you. Thank you. And just staying with you, Bruce, and then I'd like to bring you in, Greg and Darren. We've had a question coming from ICE in New South Wales. Good afternoon to you, asking, many companies fabricate unique enclosures. Councils subcontract and install new covers over existing pits. Utility workers end up not having the correct tools to access them as the manufacturer doesn't make the tools for their own covers. Thank you for that. Do you want to kick off, Bruce?
Yeah, thanks for that question. Yeah, it's always a very interesting question, particularly when you have utility locators that go out on site and they can't access covers, particularly when you have private asset owners. So up here in Queensland, where I am, you have TransLink assets, which if you go on site with that particular asset, you'll need to be escorted around by a TransLink officer who will generally have the keys to unlock those particular pits and manholes. But also in the public realm as well, if you actually have Optus assets, they do have a separate key themselves, and they are generally accessible only by those people who are accredited through the DBYD certified locator course and who have an Optus accreditation. So they will get handed the appropriate keys and locks for those assets there.
Thanks, Bruce. Greg, can I bring you in on this one?
Yeah, I think from a manufacturer's perspective, I know from an ACCO perspective, we certainly manufacture a variety of lifters, both for concrete covers, for galvanised steel covers. If we look at, say, ductile iron covers, which are, or infill covers that traditionally are quite heavy, we provide both long-handled and short-handled lifting handles to be able to safely lift those handles. So sometimes it's just education that maybe sometimes contractors aren't aware of what's available for some covers as well. but certainly from an ACAP perspective, we manufacture and provide a wide range of lifting tools, and even down to some bespoke or, say, high landscaped area access covers in terms of we manufacture a cover called an urban fill cover. So we have a specific lifting key for those that also meet the industry standards as well. So good manufacturers should be able to provide lifting keys to enable you to safely lift a lot of these service enclosure covers.
Thanks for that, Greg. Darren, have you
Greg,
anything to add?
Yes, Greg just mentioned that there is industry standard lifters, and when we say industry standard lifters, that's based on Australian standards. AS 3996 actually specify the lifting keyhole size and the lifting requirements for access covers. So when we talk about lifting key requirements in Australia, they should follow AS 3996. Most asset owners will build that into their specifications that it must meet AS 3996 with an industry standard lifter. But then you got other asset owners that might have their own lifters, and Telstra is probably a good example for that. They've got a different lifter, and their keyholes are a little bit smaller. So if you're going to sell lids to Telstra or design for Telstra, they'll have their specific lifting key tool that the cover needs to be designed to, and they're usually pretty good with specifying what they want. Telstra, but I suppose the warning for specifiers is that access covers can be imported from overseas, and overseas covers will have different lifting holes, lifting requirements, lifting keys, and I suppose if if you specify one of those, then those lifters aren't readily available, and that's where you might get caught. If you need an access to it quickly, you don't have those access lifters, then you'll be waiting around, or you have to get something custom made to lift these covers. So that's the warning of specifying covers that aren't Australian design or meet the Australian standards, that they'll use different lifters, and that's where you'll come into issues of not being able to open or access the assets because they require a different lifting method.
Thank you for that, and thank you for highlighting the importance of quality and safety in this discussion. Darren, we're moving on to cost and price. So we've had a question come in from Benjamin, who's in WA, asking, Darren, in a world of increasing prices and limited resources, have you seen much in the way of material theft? And if so, how do you combat this? Darren?
Yeah, with material theft, you would have seen some news articles that show that, there are people out there trying to make some money, and some thieves, I suppose, going to Greenfield sites where a lot of cables are being laid, very new cable, not live yet. So they'll get access to these sites and they'll pull up the cover and they'll steal all the copper. Copper's got a pretty good resale value, and it's people want to make some money, and there are people out there stealing material just for their resale value. So copper's one of the big ones. Usually, to combat this, you'll need to have a cover that can be, or a cover or a lid that can be locked down. That'll prevent them easily getting into it. But I suppose if they really want to steal it, they can bring their angle grinders in there to cut it out. I've seen some articles about having security guards on site on these Greenfield sites just to deter people from coming to steal those. Also, we've noticed iron covers being stolen too for their resale value in scrap. So, with all these covers, just got to make it as hard as possible for them, ensure they're locked down. That's a start, so it's not easily accessible. They can't just pull it up and put it in the back of the unit. But yeah, 100%. You need to make sure all your pits access covers are locked down, and then it just makes it harder for these thieves stealing the material for resale value.
Thank you for that, Darren. And Greg, just bringing you back into the discussion. Questions come in, I'm not sure who it's come from, but it's asking, do we have trafficable pit for electricity and telecoms? Greg, do we?
Look, there are a variety of pits that are available on the market now, and it's important to make sure you select the right pit for the right application. So I guess what I'm saying that there are trafficable pits, and remember there is no Australian standard for pits themselves because it's only specific to the covers. However, manufacturers should be able to give really good guidance. So, for example, when we look at traffic applications, for example, we would, if you're looking at heavier vehicles, we would look at what we would call a rigid pit. So that would be in the form of either a polymer concrete pit, concrete, or say a twin-walled plastic pit, which in the form of what we call an easy bricks pit, and they're fairly new in the market, but they're designed, they can be utilised in a Class D application when encased. However, when you look at trafficable, it's also, we'll take a good example of a footpath, which is trafficable, but in a Class B environment, which is only a 2.6 tonne wheel load. So that is still trafficable, but there'll be installation diagrams and details on how that needs to be installed. So I guess when you say trafficable, we need to look at what's the intended wheel load that's going to be put over those pits. So light duty, 2.6, maybe a car, say on a footpath or in a landscaped area, sure, can use a plastic pit, but we're talking about anything heavier than that and sustained loads, then we need to look at a rigid trafficable pit.
Thanks for that, Greg. And talking about trafficable, Richard in Queensland, Darren is asking you, are steel Gatic covers still the best technology for trafficable lids? Darren.
Just to continue on with what Greg said in trafficable lids, and I suppose his question, still AS3996 is your best guide to specify the correct load class. And if we look at AS3996, they give some general guides in their load classification tables. And for a footpath, for Class A, you're looking at pedestrian loads, so only people walking on it, cycling. Then you look at Class B, which is more your footpath loads. That's for a 2.67 tonne wheel load and the occasional traffic. So you might get a maintenance vehicle parked on the footpath on top of the pit, not for a very long time. They're just going to get access to whatever they do and then they move off. Then you've got Class C. Class C is for your minor roads and your pedestrian walls. And then Class D is your major roads. So on the carriageway of a major road, use your Class D. Anywhere with up to 80k speed limit is probably classified as a major road. And then if you're on a freeway carriageway, then it's your Class E. When you go up to F and G, you're looking at your airport aprons and wharves areas. So that's probably your best reference when looking at what traffic, what type of vehicles you've got going over it, and I'd refer back to AS3996. And with the question from Amanda just then with Gatic, well, Gatic is the acronym for gas airtight iron covers. Now, Gatic has iron covers, and they are a tried and tested product that's been used for a long time. So you'll see all throughout your main roads in your cities, you'll see iron covers that have been in the ground for a long time. So it is with iron, it's a very durable and very strong material, and that's why it's used in trafficable areas and especially on roads. You can take the constant traffic. It's very heavy, so it holds itself down, and also you can lock it down too to ensure that it doesn't come loose. There are new technologies coming out with I'll say with stronger steel covers and also plastic covers. Just beware of plastic covers. If they're not locked down properly, just because of the lightweight of them, they can easily bounce off from the vibration of traffic going over it. So the last thing you want is a cover bouncing out and exposing a hole in the ground, which is big potential hazard in the roadway.
Thanks for that, Darren, and thank you for everyone that's putting through questions. So I'll move on. A question that's coming from Raj to you, Bruce. Do we have unidentified services underground in Australia, or are 100% of services surveyed? Bruce.
Well, thanks very much for that question, Raj. Yes, it'll be fantastic if all utilities were surveyed. It would certainly make my job that I do day to day a lot easier, but unfortunately that's not the case. In a case of a brownfield site, for example, you'd have existing assets that might be owned by a private asset owner that may not actually have good asset management principles, and they may just be put on the ground by whoever or whenever, and those are not logged. So, of course, when the brownfield site then becomes available, all these assets are currently sitting in there that have no record or anything like that. But conversely, on the public world, using Before You Dig Australia, some of those plans from the asset owners are certainly not up to date, or in some cases, recently we found out some projects where the information shown on the Before You Dig Australia plans is actually design information and not as constructed information. So it can vary, but bear in mind that you Die Before You Dig or Before You Dig Australia information is actually used as a guide. It's meant to show you, is there an asset there or isn't there? So that's where your conversation with the utility locators comes on, or talking directly to the asset owner to obtain more information.
Thanks, Bruce. Does anyone else want to jump in on that one? We'll move on. A question that's come in from Rebecca. Good afternoon to you, Rebecca, asking to you, Darren, what happens if you don't anticipate traffic being in a footpath and then a vehicle parks on it? Who polices that? Darren.
I suppose there is no one really policing that. You've just got to think about what's the worst case scenario for that application. If you think that is accessible by a heavier vehicle than it should be, that could be a potential risk to your asset. And if that's the case, then what you'll do is specify a higher load class product. So instead of using a Class B lid for a footpath, if you're going to anticipate some trucks, big delivery trucks going to go over it, could possibly park on it, then you might just want to specify that pit in that specific location. There's going to be a Class D, just to protect the pit and from damage, and just ensure the durability of the pit. It doesn't get damaged over time.
Thanks, Darren. And just staying with you for the moment, a question that's coming asking, what is the design life of the plastic pits? Darren.
Yeah, with plastic pits are either made rotational molded with polyethylene or injection molded with polypropylene. As we all know, plastics are very inert material. Nothing much really affects it, so it's going to last a long time. One thing that can degrade it is UV. So with most plastics these days, there's UV additives put into it to protect it from degradation from UV light. So, look, these pits can last, 50 years, 100 years. It depends on the location. There's no nasties, nothing's going to happen to it during its life. It's going to last a long time. So I'd say easily over 50 years design life. If I had to pick a year.
Thanks for that, Darren. We've had a question that's come in from Ash. Good afternoon. And Greg, I'd like you to comment on this from the pit side of things. Ash has asked a great question. What happens to the cables that are submerged due to flooding or a rise in mean sea level? Greg.
Yeah, thank you. Yeah, and we know a bit about flooding from recent events. Look, there's, and we touched on it earlier when Darren was, we spoke about drainage in the bottom of pits. So I guess, if it's in a flood-prone area, I guess then you do want to consider having drainage in the bottom of the pits out to some a gravel pit or a soak-away pit, so that it can eventually drain away. Outside of that, there's probably not a lot you can do in floods other than just wait for the water to recede, and then importantly after that, then those services need to be checked before they become live again for reuse.
Thanks for that. And Bruce, Henry's asked a question about step irons, asking, are these still specified and in use, or should access into pits be risk assessed? Thanks, Bruce.
Yeah, thanks, Henry, for your question. Yes, they still are specified, but again, it comes back down to the case-by-case scenario where the asset owner, whether they would like to use the step irons as a means into the pit chamber, or whether they would have a tripod and a winch scenario going on. But it would just primarily come down to the safety design principles, the accessibility of that pit chamber, and whether step irons are actually required by the asset owner themselves.
Thanks, Bruce. As always, we're getting rapidly to the end of this session. So what I'd like to do is we've talked about a lot this afternoon and we've covered a lot. And starting with you, Bruce, is to just leave our audience some of the key takeouts from today's presentation that you delivered. Thanks, Bruce.
Yeah, thanks. It's from my perspective, just to understand the existing utility data that you actually have, and obviously understanding that sometimes we're dealing with newly installed pits in quite poor conditions that may reduce the design life of the pit and chamber. But also to understand the differences between trafficable and non-trafficable, that the ACO team here actually can assist the designing and engineering world with all sorts of queries and things like that. So yeah, so certainly contact them. They have their engineering department behind the scenes that can actually help you with all sorts of inquiries.
Thanks, Bruce. And Greg, Darren, how you want to handle this? Greg, do you want to just leave our audience with some key takeouts for this afternoon?
Yes, I think that the key thing to remember is there are different pits for different applications. So it's really important to understand how the closure is going to be used, where it's going to be used, then serviceability, security, because often when those things aren't considered in the early stage of the planning process, that's when often things can go wrong. So yeah, really important to understand different pits for different applications and make sure you get the right one. Darren?
Thanks, Greg. Darren?
Yeah, I think to correctly specify a pit, you need to really understand at least the Australian standards, AS3996, and the load classes. Once you understand that, you can find products from different manufacturers that specify what load class there is. So that's a starting point. Learning about understanding your load class and specifying the right load class for that pit location, and then specifying the right product for that application. So that's key for a long-lasting, durable installation.
Thank you, Darren. And Greg, I just want to finish up with you. As we know, we've had a lot of severe weather conditions. There's a lot of, with climate change, we have a climate change engineering conference. Greg, just quickly, what advice would you have for our young engineers that are looking at this field and for them? And I've deliberately kept that question broad. Greg.
Yeah, look, it is a ever-changing environment, and certainly the questions that we are fielding is in response to a lot of those changes, whether it be from an ACO perspective where we manufacture a variety of products for different applications. So while today is specific around cable enclosures in the form of pits, we also manufacture a variety of other products for other applications, in certainly in surface water management for drains, subsurface drainage in the form of stormwater retention, detention and attenuation. So I think moving forward, we need to often consider manufacturers that can support you in your project. So with the ever-changing environment, manufacturers need to be adaptable. We are very adaptable and can provide really important advice to make sure that what you're looking to design is fit for purpose and has the desired outcome. So for young engineers, certainly look for those manufacturers that can really drive and help you with that support, not just look to sell you a product. It's actually give you that in behind support, which is really important, which is why I think from an ACCO perspective with our Ask ACCO, www.askacco.com.au is really important.
Thanks, Greg. Thank you. And as always, that's all we have time for today. Please join me once again in thanking Bruce Potter, Greg Facey and Darren Chan for their time and input. I'd also like to thank Engineers Australia's industry partner, ACCO, for their support. Please take a couple of minutes to complete a short feedback form, which is linked in the description box below, to help us improve and plan for future sessions. Thank you again for joining us, and we hope to see you at our next Thought Leaders event. Good afternoon.